Hey Algebra, we're going to take a look at lesson 3.2 today, and it's talking about inequalities and solving those with addition and subtraction. Now, the way this works is just like it would work with equations as well. We're really just moving things from one side to the other using addition and subtraction and simplifying as much as we can. Okay, we're going to start off with this weird formula, and you can see I've written it down here for reference. But what this is a formula that's used to rank the passing efficiency of a quarterback at the college level. Now, if you've been around sports at all, you have a ton of numbers representing things, okay? And I want you to understand that in that world, the world of sports, actually mathematicians are in great demand. People are looking for statisticians, somebody who understands data that can create formulas to figure out the efficiency of a player, because they're investing millions of dollars in these people. So this is designed to figure out kind of overall how does a quarterback rank in passing efficiency. And it takes into consideration the distance of the throw, a completed pass, a touchdown, interceptions, attempts, and incomplete passes. Okay, each of those weighted in different ways, counting with different values to give an overall again, rank to individual person. So up here you have this. It says work with a partner, but we're going to do this together. Which of the following quarterbacks has a passing efficiency rating that satisfies the inequality? P is greater than 100. So we want their rating to be greater than 100. And really all this means is plugging into things here. So each letter represents something in our equation that we have. And really all they're asking us to do is punch this in. We're just going to do one, okay, to see. And what they're asking us is, could you solve this using addition and subtraction to get an answer? So for player A, the number of attempts is 149. Notice that's on the denominator. In the denominator, that's what A is. Okay. Completions is 88. That's the C. So I'll write out my equation here. Okay, there's that 88, by the way, is right there. Parentheses. I think the last one is minus 200. Okay, so 149 attempts, 88 completions. Yards is 1,065. That goes right here. Touchdowns is 7, and interceptions is 9. And what we're trying to do, and I would actually grab a calculator and do this, is adding all the numerator up, dividing by 149, and we're trying to figure out, is that greater than 100? Here's my calculator. We're going to punch this in really quick. All right, and we get 122.52. So this player, A, would be greater than, A would be greater than 100. So again, this isn't super hard. If I plug it in, P is this really large equation, and they're just trying to make you walk through this. Now, the reason I'm going all over all of this is because this equation right here is going to be in your homework. Okay, so when they mention using the equation, if you see those questions, refer back to this in your notes. It's also in your book. Okay. All right. This one also tries to let you give some ideas where basically you get less than 0, and you can come up with some crazy thing. Okay, maybe they make 1 attempt, 0 completions, 0 yards, 0 touchdowns, and it's an interception. Okay, that would give you basically a negative number because of the negative 200. What if they put a 100 here? Oh, now that changes things. Notice we could do some math here to actually solve this before we attempt this problem. We would subtract 100 from both sides. And this is really what we're getting into today. Okay? So the idea is simply this. Okay? The addition property and subtraction property of inequality tells you that if an inequality is true, and you do the same thing to both sides, like I add 4 here on both sides, the inequality will still be true. That's the same for algebra. If you have x minus 3 and you add 3 to both sides, then x should still be greater than the other side. Okay, so what we're going to do is add or subtract on each side of an equation. Again, the situation they're giving you here is simply getting you to try to work with formulas, work with numbers to solve and get an answer. Okay, so on this problem, all they're asking us to do is solve the x by getting it all by itself, which means we're just going to add 6 to both sides. So you get x is greater than or equal to -4. When we're graphing an inequality, as we talked about yesterday, this is going to be a closed circle. So I'm going to start with -4 here, closed circle. And number line goes backwards when it's negative. Since x is greater than, it's going to be this way. These are the numbers that are greater than -4. Okay, so all we're, sorry about that. There's some u tries here. And all we're going to do is walk through these again. I'm going to walk through all of them right now just because I think it's helpful for us to practice. So again, making sure. Really, I know that started off with this weird formula. Why are they giving you that? Just to, let me step back for a minute. They're only giving you that just to make sure you're comfortable with. No matter how crazy things get, all we're doing is adding, subtracting, multiplying, dividing in order to simplify and solve for a variable and determine a situation. A real life situation, as we're comparing maybe something like quarterbacks or something like that, where you would have to plug that in. Even on the exit ticket the other day from class, right, where I was asking, come up with a real life situation where you would use this inequality. I know I've mentioned to people, we talk about height, you could talk about money. We have only this amount of money spent, so you have to spend less than that. Or maybe to get a discount. I know if you want free shipping a lot of times, you have to spend at least this amount. So this is where these inequalities come into play. So on all of these, all we're doing now mathematically is, if I want to solve a variable for a variable, solve an inequality, it works just like an equality, if this was an equal sign, where we move variables over. So I'm going to add 2 to both sides, and you get b is greater than -9. And the idea is simple. The idea is this. Again, I want us to see it. Okay. If you have an inequality that's true, which they're telling you these are true, if you do the same thing to both sides, the inequality will hold. Okay. They asked us to graph these, and we will get to that in just a second. So this one, doesn't matter if it's a decimal. You can do that to both sides. M is less than or equal to 8.8. Okay, and it doesn't matter if they're fractions. If I add 1/4 to both sides, okay, 1/4 plus 1/4 is 2/4, or I'll make that a fraction. 1/2 is greater than y. Typically, when we do these, we'll do y is less than 1/2. Typically, we're going to put the variable first. That's kind of how we read it. Sorry, this is an 8. We're going to solve this. So on this last one, I just want to mention these. If you have decimals, sorry about that. If you have decimals or fractions, I think we're okay on that first one. If you have decimals or fractions, one of the things that's really helpful is just to change the scale. So maybe I have this like 8.8 here. Maybe I just go by ones and I just do 9.8, 10.8, over here 7.8. 6.8. Just a different way to do it. You could go by, by 0.2 and go 8.8 and then 9, 9.2, 9.4. But this is an easy way to do this. This would be a closed circle because of the equal to, and my arrow would go this way. It's less than that. When it's fractions, okay, sorry. When it's fractions, one of the things you can do is, I'm going to put a 1/2 here, is you can convert to decimals, but what you could also do is go up by halves, right? So just go by halves. This is not too bad to go up by 1/2. So 1/2, 1, 3/2, 2, 5/2. And what I want you to see is there's actually a pattern with the way I wrote these. I just didn't write them. This is 2 over 2. and this is 4 over 2. So notice it's 1, 2, 3, 4, 5, and I'm just increasing by half every time. And you can leave them with this awkward kind of fractions that maybe would be a little bit simpler. On the other side, it would be, if I was going, notice it went 1, so this would be 0 divided by 2, which is really just 0. This would be negative 1 divided by 2, and negative 2 divided by 2. Okay, open circle here. Y is less than that, so we're going this way. Okay, so as we graph some of these, just some helpful hints for you. Okay? So this one, again, very similar. We're going to subtract 1.4 from both sides. Be careful about your adding and subtracting here when they're both negative. This means you have a large negative number. It's getting bigger, more negative. And again, I'm never going to leave them this way. The way I'm going to write them is always from the perspective of x. So x is less than negative 9.4. Okay? So I just want to make sure I do this for two reasons. Number one, this is the way we should read them from the perspective of the variable. So even when I write it this way, it's x is less than negative 9.4. But the other reason I do this is if the letter is on the left, I mentioned this the other day, that this arrow tells me which way to draw. So if I'm going negative 9.4, I'm going to put my arrow going this way. Before I've even done anything, I know that that's the way my arrow should go. I have to make sure my numbers match this. Again, I'm going to stick with whole jumping up here by decimals. So I'm going to keep my 0.4 and just go 10.4, 11.4, and spread out. Okay, if your scale doesn't match mine exactly, let's say you did something like this, negative 8. What you don't want to do is jump, and the reason I'm doing this by ones is you don't want to jump uneven amounts. So if I put 8 here, to go from negative 9.4 to 8, that's a difference of 1.4. So the next number shouldn't be negative 7. It should be like negative 6.6. That's why I don't encourage you guys to jump to whole numbers right away. You want your scale to be even. So just go by ones and leave the decimal there on that. Or come up with a creative way to do that. Maybe you go by 0.2, so that's not too bad. Negative 9.2, negative 9, negative 8.8, so on and so forth. Okay, this should say example 3. Okay, a train, on a train, carry-on bags can weigh no more than 50 pounds. Okay? They have to weigh no more than 50 pounds. So my carry-on has to be less than or equal to 50 pounds. It can be 50, but it has to be less than that. Okay. Your bag weighs this. It says write and solve an inequality that represents the amount of weight you can add to your bag. So my carry-on currently weighs 24.8, and I want to add a certain amount to that. I don't know how much that is, but it still has to be less than or equal to 50. This is your equation. So that it says write, I just wrote. And now it says solve. Now solving means I'm going to solve this. I just have to subtract 24.8 from both sides. And I can add a total of 25.2 pounds. If I subtract those, you get 25.2. Okay? Notice the similar kind of question. Your carry-on bag weighs 32 pounds. So all that's doing is changing this to a 32.5. So don't be thrown off if there's an extra one or additional one. Think through the logic of it. Nothing's really changed. They just made your original bag heavier. Okay, this is actually a real life situation, right? Anytime you go on a plane or you're packing somewhere, there's certain requirements for weight. I know when I go backpacking, I'm trying to keep my pack as light as possible. But I also have my kids' packs to consider. So that's what I do. I sit there and I'm like, all right, this son can carry this much, this son can carry this much. And then I kind of get all the leftovers, whatever it is, right? So, but there's requirements. There's a certain amount that I have to consider as I'm working in, kind of loading up our packs to go for a little trip. All right? So I've got these two problems here, and you'll see these on the Ed Puzzle for you to answer. If you have questions, you can always jump on Zoom, and I'll try to help you out and clarify on there as best as I can.